All right, with this video, I'm going to have to skip over number 7 and 8, only because I want to get my Inspire on here and I'm going to figure that out. So I will upload that tomorrow. So we're going to start down with number 9, and we want to figure out where this function is increasing and decreasing or when it's constant. So constant is going to be our horizontal line. And again, this is going to be in chunks like we're reading the domain. It's always going to be our x values. So from right here to right here, this function is constant. So we're looking on our domain, on our x-axis, where is it constant? At negative 1, 2, 3, 4. So negative 4 all the way up to negative 1, our function is constant. Then from negative 1, it starts to decrease. So we want to know right from here all the way to here, it's decreasing. I'm not worried about the y values, I just want to know where on the x-axis. So it's decreasing from, we're starting at negative 1 all the way to 1. And then from there, it's going to start increasing. So from 1, and hey, it's going to infinity. It's going to keep going and going. So from 1 to infinity, this entire function will continue to increase. So look at these in chunks. X values, we want the x values, not the y, not points, doesn't matter. We just want to know what sections, what's happening in my sections of my domain. Then we want to, again, use a graphing utility. So I'm going to do another section of this later. So we're going to jump down then to page 3. Up. Okay. Still getting used to working this. All right. Determine symmetry. If graphically, if we have a graph, remember there's that ooh, yes. So I'm going to write that down. We have oh, yes. All right, so this is y-axis. If graphically your graph is symmetric on the y-axis, then you have an even function. If algebraically you plug in your negative x value and your function remains the same, you have an even function. For odd functions, if your graph is opposite, or I'm sorry, it's symmetric about the origin, you have an odd function. When you plug in your negative x into your function and you get the opposite of your function, you have an odd function. So, ooh, yes. Try and remember this. It was in our notes. Ooh, yes. So if you take a look at number 11, there is symmetry along the y-axis. Symmetrical along the y-axis, so this is therefore an even function. Here we have our function that has this rotation going on, so it has symmetry about the origin, so it is an odd function. Now we want to actually look algebraically. So here's graphically. Now algebraically, we want to plug in our negative x. So I'm going to plug in f of negative x. We're going to change it to the opposite. So I'm going to have negative x over negative x to the 5th minus 1. This is going to stay the same, so I'll have negative x on top. Negative x to the 5th, if it's an odd function, it's going to stay negative, minus 1. So it's not the exact same function. It is not even, because we have a negative now here and a negative here. If this turned into a positive one, it would be odd, but it's not. So this case, we have neither. Okay, now let's plug in our opposite x find out what happens. So if I have negative x to the fourth plus 3 times negative x squared. Again, I have an even exponent for both of these. Anytime I have a negative number and I raise it to an even power, it's going to turn positive. So this is going to turn into x to the fourth plus 3x squared, which is the same as this. So if it's the same, it is even. And the last function, again, we need to plug in negative x. So f of negative x equals negative x cubed plus 3 times negative x. That's going to give me negative x cubed is going to stay negative. And then 3 times negative x will change that to negative 3x. In this case, change color here, if we were to look at the opposite of this function, where we would multiply everything by negative 1, it would turn my function into negative x cubed minus 3x. So it's not even because it's not the same as this. Both of these change just like this, so this is an odd function. All right, let's keep going. Oh, piecewise, so fun. All right, so we have two pieces of this function where x is 5, where usually we would go up to 5, 1, 2, 3, 4, 5, and we would just draw a horizontal line. But in this case, any of my x values have got to be greater than or equal to 2. So I need to actually go over to 2, and I'm going to have to erase this whole section. I need to get rid of it because it has to be greater than that cut line. Right, so you can think of it like that, or just make sure that you're drawing. This is where you're going to be cutting off. It's your cut line right here. And our positive 2. And this first piece is going to start right on 2. It is equal to it, and it's going to continue to go this way. It's going to be greater than, so it's going to be this way. Then our second function, is going to be less than, so we're going to only draw it to the left of our cut line. If I want to know exactly where I am on the cut line, I'm going to plug 2 into my equation. So 2 minus 3 is going to give me negative 1. I plugged in 2, I got negative 1. So add 2, I'll go down to negative 1, it's going to be an open circle. Then I want to know what my slope is, so I can start to draw my graph. And again, we're only staying to the left. And we would be going up 1 over 1, but I can't go this way. So I'm going to go down 1 to the left, down 1 to the left, and draw my line this way. So domain of this function, we're scanning this x-axis. We're going, going, going. This is going to continue to go on. So there is something in these x values. Even when we get here, though, this is open, but this is closed. So there is something on 2, and then it continues to go on. So the domain of this function would be at negative infinity to infinity. And my range, I'm starting down here, coming up, 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 up. But now there is a stop. There is a halt. There is nothing happening in here. So I'm starting at negative infinity, but I'm stopping at negative 1. That's an open circle. All right, then I'm going to keep going up. There's nothing going on here, here, here. So at 1, 2, 3, 4, 5, range is occurring, but range is only the y value. So then again, there's nothing above it, but there definitely is something at 5. So that's going to be closed brackets. So negative infinity to 1, and then 5, and that is it. And x-intercepts, we want to figure out where is it hitting on the x-axis. Well, in this case, there's none. Nothing's going on. No lines are crossing, but we are hitting right here on our y-axis. So we're at 0, -3. That's our y-intercept. Intercepts are always points, always written as points. And the last one, let's go backwards now. We'll start first. We can start with this little piece here. So we want to figure out what the restrictions are, and the slope, and the intercept. So we're coming from -infinity, and we're going to stop at 1, 2, 3, at 3. So when my function is less than and equal to 3, I can draw this area. Right now, the slope, we want to kind of figure out, is going to be down 1, 2 over 1, 2, 3. So my slope is a -2 over 3. And where I would hit on the y-intercept, I would be right at 1, 2, 3, 4, 5. So plus 5. And my next one, my other little chunk here, from here to here, it's being restricted at, it's between 3 and 1, 2, and 6. So when my function is between 3 and 6, and I know it's less than 6, or equal to, because it's closed, and it's greater than 3, I have a horizontal line at 2. And that's it. Okay, so that's it for this one. I will start another video in just a few minutes.